problem, and this is a fairly typical calculus problem. There is an applet. If you follow that link, you can see the applet kind of visualize what's going on. But this person is, if he's 6 kilometers from the shore on the water, and he's 10 kilometers from that point on the land to point B. He's trying to get from A to B. Now the shortest distance is going to always be a straight line, but if he does that, he's going to be swimming the whole time, and he can't swim faster than he runs. But if he goes straight here and minimizes swimming, he's got the most distance that he's going to travel here. Okay, he's going to go maximize amount of time on land, which is good, but he's also going the furthest possible distance if he does that. So somewhere in between is going to optimize his time. Okay, so first of all, we just need to make sure that we remember that our little triangle, right? The distance is velocity over time. Okay, so if I want to minimize time, so if they need to get from what angle normal should they swim, so they want to go get there the fastest point, the fastest way they can. So we want to minimize time. So I need an equation for time. So time on the water is going to be the distance on the water over the velocity on the water. Time on land is equal to the distance on the land over velocity on the land. Okay, so you've been given the velocities on water and land. We just need to figure out distance on water and distance on land. Okay, so this is going to be, I'm going to set this up this way. I'm going to call that x. And the distance on the land is straightforward. That's going to be 10 minus x. Okay, so I'm just going to rewrite that. So time on land is going to be 10 minus x over the velocity on the land, which is 15 kilometers per hour. The distance along the water is going to be that distance there. In terms of x, well, I can say that that's going to be x squared plus 6 squared equals that squared. So that's going to end up being 36 plus x squared square root. Now notice that I'm doing it in terms of x and not theta. I could do it with theta, but it's probably easier to do with x, and once I find x, I can just find theta by using, in this case, probably arctan or something like that. So that's what I'm going to do. So my time on water is going to be the distance on the water, okay, 36 plus x squared over the velocity on the water, which is 3. And I want to minimize that total time. Okay, so I'm going to write the equation. So my time total is going to be the time on the water. So here's my time on the water plus my time on the land. So the distance divided by velocity on the land, which is time. And I want to find the minimum time, so I'm going to differentiate this. So I'm going to end up with 1/3, 1 over 2 square root 36 plus x squared times 2x using chain rule. This is going to be, well, that's 10 over 15 constant, which is 0. So I'm going to differentiate negative 1 over 15 times x, or my slope is going to be negative 1 over 15. And I want to find out when that's equal to 0. Now I have my equation. I'm going to simplify this a little bit. So my equation equal to 0, I'm going to end up with x over 3 root 36 plus x squared, and that's equal to 1 over 15 on the other. I'm just going to move that 15 to that side there. Okay, and solve this equation. I'm going to end up with 5x equals square root 36 plus x squared by cross multiplying that. Square both sides to solve for x. So I'm going to end up with 24x squared equals 36. X squared equals 3 over 2.
So x is equal to plus minus square root 3 over 2. Okay, so we're gonna go really kind of pretty sharply that way. Okay, so then if that's equal to 3 over 2, I still need to solve for theta. So theta is going to be the arctan of opposite root 3 over 2 over 6. So calculating my theta. For my calculator, what am I going to get here? I'm getting an angle of 0.201, so I'm going to round that to 20 radians. Okay, so that angle in here at 0.02 is going to give me the best angle to minimize the time to get there from A to B the fastest.